Okay, so now I'll be basically we'll be doing the question bank, chapter 4. All right, basically the last part of your syllabus already. So the first question, I'll go through the questions quickly. Those that are simple, we'll just go through it. All right. A teacher travels to school by car. She sets out from her home at 8 a.m. exactly. The time taken for her journey can be considered to be normal distributed, so you know it's a normal distribution. And if they don't even tell you that, you should already know, because the mean and standard deviation is given to you in the question. So the mean of 15 minutes, standard deviation 2 squared. All right, so time taken to travel. So the first part asks you exactly 15 minutes. You should already know this by now. Now, if it's normal distribution, exactly 15, it will be 0. You don't need to change to z-score and find, because if it's exactly, the probability will be 0 for normal distribution only. All right, more than 18 minutes, because this is normal distribution, it will be more or equals to 18. Okay, so this is where students always get confused. You must always think, my original distribution is normal, so if it's more than, I change to more equal to. If it's less than, I change to less or equal to. But my original distribution is binomial, is Poisson. If I'm saying more than 18, I'm saying 19 and above. So do not confuse yourself, because this is a normal distribution question. More than 18 becomes more equals to 18. This is a common mistake within students, all right? So it becomes more equals to 18, you change it to z-score, find the probability. Same goes to this, between 15 to 18. If it's Poisson or binomial, it will be 16, 17, correct? But this is normal. So if it's normal distribution, 15 to 18, x is more equals to 15, less or equals to 18. 15 to 18, in other words, is included in whatever it is that you're calculating. Find z-score, find probability. By now, finding z-score and probability, it should be in your fingertips. You have done too many questions already. All right? Then you have question 2. The weight of newborn babies are assumed to be normally distributed with a mean of 3.5. All right? And the standard deviation of 0.5. You write your event, you write your distribution. Okay? What is the probability that a randomly chosen newborn baby has a weight of between 3 and 4.5. So this is normal distribution, right? You're answering using normal distribution. So x will be more equals to 3, less or equals to 4.5, must be included. For normal distribution, it's always more equals to, less or equals to. Understand? You find your probability, you find your z-score. It shouldn't be a problem. Again, this is normal distribution, exactly 3.5. Your answer will be 0. You can change to z-score, no problem. It'll be z equals to 0. If z more equals to 0, it will be 0.5. Z lesser or equals to 0 will be 0.5. But z exactly, then it will be 0. Okay? When your z-score is exactly, it will be 0. Alright? Now, if 4 newborn are randomly chosen, the moment you see something like this, you know it is going to be a binomial distribution. Why? Because the n is given to you. The moment randomly chosen is there, is a binomial distribution. So you know your n is 4. What is the probability the 3 of the 4 babies will be heavier than 3.5 kgs? So how to find this? Heavier than 3.5 kgs. Okay, so now they want, what is the event? Number of babies heavier than 3.5. They ask you what is the probability 3 out of 4 babies will be heavier than 3.5. So your event will be number of babies heavier than 3.5. Your n will be 4. Understand? Your n will be 4. Okay, why 4? Because 4 here, randomly chosen. How did I get a p of 0.5? You will get it because you need to find the probability. You need to find the probability that the baby is heavier than 3.5. How to find that? You need to use normal distribution. P x more equals to 3.5. You change to z-score. You get z more equals to 0. This will be 0.5. So that's where I got the 0.5 from. Alright, so this is where students always go wrong. Understand? So the 0.5 comes from here. Okay, the P is always related to the event. When it comes to binomial distribution, your P is always related to your event. If number of babies heavier than 3.5, you must find the probability of the baby being heavier than 3.5. Understand? Now we want what? 3 out of 4 babies. So probability of y equals to 3. Because you want to find 3 babies, right? Put it into the binomial distribution equation and find the probability. Your answer will be 0.25. All right, your answer will be 0.25. All right. Moving forward to number 3, pause as you're doing the question so you can follow me as we are doing it, all right? Question 3, assume that the t-scores are normally distributed. So you write your event, you write your distribution. Please don't forget that. I'm looking at some of your work. Still, I don't see some of you writing event, distribution, and if you're changing, I don't see that asterisk. So make sure all these are little things that you need to make sure is there. All right, so this is normal distribution, so I don't need to go through it too much. If it's less than 58, it straight away becomes less or equal to 58. This is normal distribution must be continuous. Normal distribution must be continuous. Do you see that? Okay, so I don't want to see the same mistake. Now, this part, if 10 scores for this subject is selected at random, you know this is binomial distribution. The n is 10. This part tells you is binomial distribution. Calculate the probability that no more than 3 scores, so you're calculating the probability of no more than 3 are less than 58. So what is my event? Number of scores less than 58. So I will have a binomial distribution with an n of 10. How do I know what should my p be? My p must be related to my event. What is my event? Number of scores less than 58. So here must be the probability that the score is less than 58. So let's go back up. Do we have it here? Yes, less than 58. You already calculated it. 0.5. So you got, that's where the 0.5 comes from. Understand? Okay, so you will see questions like this where originally is normal. Then they'll ask you to make it binomial, or originally is binomial, then you have to change it to normal, that sort of thing. So you got to get used to it both ways, all right? So you do not get confused, all right? So n is 10, your p is 0.5. So y less or equals to 3, you know why, right? No more than 3 scores are less than that. So no more than 3, 0, 1, 2, 3, isn't it? Use your binomial distribution formula and solve the problem. Okay, if 200 scores are selected at random, pretty much, this is a binomial distribution. Your n is 200. Do you see that? Great. Calculate the probability that no more than 50 scores are less than 50. So what's my event? Number of scores less than 50. So these are the things you need to highlight when you read the question. The moment you read it, you highlight 200 scores selected at random. Oh, that means this is binomial. Calculate the probability. The moment they say calculate the probability, this is the part where you're talking about. No more than 50. Straight away, right? PR less or equals to 50. You want to use X also, not a problem actually. All right. More than 50 are less than 50. So this part is my event. Number of scores less than 50. So I must have my n, which is 200 from here. My p must be the probability I score less than 50. So let's look up here first. Do we have it? Oh yes, we have calculated. If you haven't calculated, like just now earlier, you have to do it on the side. If you have already calculated, most of the time in the exam, you have already calculated it. So you don't have to worry. So you already calculate. It's here, 0.3085. So my p will be 0.3085. Okay? Scores less than 50. Can you do it one by one using binomial? No. This is more than 10 probabilities ready, so you're going to change it to normal. So you have the asterisk, you find your mean, you find your standard deviation. R is less than 50, okay? So you will change it to, okay, this is actually wrong. So, sorry, calculate the probability that no more than 50 scores. So R lesser or equals to 50. No more than 50 scores. So R is lesser or equals to 50. Lesser or equals to V plus 0.5. You change to Z score, find the probability. Okay, question 4. So from now on, it's going to be very repetitive, so I'll go a little quickly. When Michael plays basketball, his free throw percentage is 40. So let X be the number of free throws. So your M is equal to 20. This is your binomial distribution with the N of 20. Your P is 0.4. This is very direct. 7 or 8, you take the probability of 7 plus with the probability of 8. Here they already told you directly to use normal approximation. You just follow. Your n will be 100, p will be 0.4. You find your mean, find your standard deviation. 45 to 50, if inclusive, this is what it means. X is more equals to 45, less or equals to 50. Inclusive tells you 45 and 50 is included in whatever it is that you're calculating. Understand? Then you have to do your continuity correction. Why you must do continuity correction? You're changing from binomial to normal. That's why. Understand? Like here, I don't need to do it because originally it's binomial. I'm using binomial to solve the problem. Understand? So don't confuse yourself. This is originally a binomial distribution. You're going to use normal to answer. That's why. Okay, question 5. Two species of fish A and B look very similar and can only be told apart by an expert. So now you have the length of fish caught. You have A, this is for A, this is for B. It's all respectively in the question, so you just follow accordingly, all right? So this is for A, your mean for A, standard deviation for A, your mean for B, standard deviation for B. A fish is caught that is less than 17 cm long. This is a normal distribution, right? So if it's a normal distribution, if I were you, I will directly write it down. Oh, less than 17 means lesser or equal to 17. So you won't make the mistake. Original is binomial. I'm answering a normal distribution question. I'm answering it as normal. So you must make sure you know normal must be lesser or equals to. Justifying your answer with appropriate correct, state whether fish A is more likely. When they ask you which is more likely or not, you got to calculate the probability for both and see which one has a greater probability. So XA less or equals to 17. You know why it's less or equals to 17? Because this is normal. I didn't change anything. I'm using normal distribution. So normal distribution is continuous. It will be less or equals to 17. XB less or equals to 17. So for A, you use the respective value for A. For B, you use the respective value for B. So for A is 17 minus 25, divide by 4. For B, you take 17 minus 30, divide by 7. So you will get your z-score accordingly here. Okay, then you will find your probability as well. This shouldn't be a problem. So species B will be most probably be B. Why? Because B has a higher probability. Understand? Okay. Now 10 fish are caught. This tells you they're giving you n. If they're giving you n, what does that tell you? This is a binomial distribution now. What is the probability that at most 6? So what is the probability at most 6? We are calculating this probability. That is why you see it here. Do you understand? Of them are less than 30 cm long. The last part is always my event. Number of fish caught less than 30 cm. This is what I want you to get. I need you to get the hang of it. Normally the first part of the question is your n. The second part is the probability that you are going to calculate that you see down here. The last part is usually your event. Alright, number of fish caught less than 30 cm. So my n is 10. My p must be the probability that the fish is less than 30 cm. Since we are talking about species B, we will use the normal distribution for species B. Alright, lesser or equal. Why did I change this to lesser or equals to 30? This is normal distribution. I'm using normal distribution to answer. It's continuous. Alright, so it will be lesser or equal to 30. I find my z-score lesser or equals to 0, 0.5. Okay, so you put 0.5 here. That's where it comes from. Alright, so what's the probability that at most 6? Y lesser or equals to 6. So you got to use binomial distribution formula to answer the question. Whichever way you want. You want to do 0, 1, 2, 3, 4, 5, 6. Up to you. Or I think this is shorter. 1 minus 7, 8, 9, 10. You can do it, but binomial got limit. So you can do either way. Alright. 200 fish are caught. So this also tells you again, this is going to be a binomial distribution. What is the probability that less than 45? What is the probability less than 45? This is what we are calculating. Less than 45. Do you see that? Are more than 29 cm long. This last part is my event. Number of fish caught more than 29 cm. N is 200. Do you see it from here? The N is 200. My P must be the probability of the fish caught more than 29 cm. Since this is A, I'll be using the normal distribution for A. So more than 29. This is normal distribution. It becomes more or equal to 29. You change it to z-score. 29 minus 25 I will use for A, okay? Divide by 4, you will get 1. Your z-score will be 1. So z more equals to 1. The probability is 0.1587 goes inside here. I know it will take time for you to get the hang of it, but you must, because this is how your exam questions will look like. Now, what are they asking me to calculate? Less than 45. Can I do this manually? Cannot. So you got to change it to normal. So make sure you put the asterisk. I see some of you, when you change to normal, you don't put the asterisk. Please make it a habit, because at least you know, oh, it was originally binomial. I'm changing it to normal. So when you have that asterisk, you know you must do continuity correction. Okay, you find the mean, you find the standard deviation in 4 decimal places. Less or equals to 4 becomes less or equals to 44.5. Okay, then you change it to z-score and you find your probability. All right, this is a past year question actually. So this is how your questions will look like. Question 6, this is quite simple. This is originally a normal distribution question with your mean of 30, standard deviation of 10. What is the probability that Lee is late? How to know that she will be late? Lee is supposed to be at work at 9. Okay? So if supposed to be at work at 9, that means she arrives later than 9. She has left home at 8:20. Meaning, 8:20 she leaves. Okay, she's supposed to get to work at 9, meaning that's 40 minutes. Meaning what happens? It took her more than 40 minutes, correct? And I understand your logics here. If I'm saying more than 40, should be 41 and above. This is normal distribution. If I'm saying more than 40, it should be more or equal to 40. Okay, then you find your z-score and you find your probability. All right, so that is the explanation to this. Many students will ask me this. So how is she late if she arrives later than 9? How to arrive later than 9? She has taken more than 40 minutes to travel. So more than 40 minutes, because it's a normal distribution question, it becomes more equal to 40. All right, so your z-score is 1. You find your probability. Now, if Lee works 233 days a year, and always starts from home at 8:20, on how many days in a first year can she expect not to be late for work? All right, not to be late for work. So this is the probability that she was late, right? So 1 minus this will give me the probability that she's not late. All right, so how do I find the expected? N times P, my N is 233. P is the probability that she's not late. You put it down there, that is your answer. Expected value, don't forget, it's your mean N times P, all right? Question 7. Susie bought a 3-hour videotape to record a film to be shown on TV. The brand of videotape she chose has a length normally distributed, 185, 2 square. What percentage? So when they ask you percentage, just make sure you follow the question and give the percentage. Have lengths less than 3 hours. Less than 3 hours. This is in hours. Your question given you in minutes. So it's your duty to change the hours to minutes. So I know less than 3 hours is less than 180 minutes. But this is normal distribution. It becomes lesser or equal to 180. Then you change it to z-score. This is your probability times 100. It's your percentage. Including all the credits, the film that Susie wants to record is 3 hours and 7 minutes long. That is 187 minutes long. What is the probability that Susie can get all of the film credits on her tape? So just find the probability. X more equals to 187, change to z-score, find your probability. Okay? All right, next one. This is a normal distribution again. All right? Okay, shh. There are 2 requirements, the new engine, and you have basically, everything is given to you in the question, so you just follow accordingly. What proportion of pistons is too big to meet the requirement for new engines? Too big for new engines. So what is new engine? So read the question here. Okay, there are 2 requirements of piston size. New engines require between 99 and 101. So if too big means bigger or equals to 101. Why didn't I just say bigger than 101? This is normal distribution. It's continuous. So if I'm saying bigger than 101, immediately you must know it's bigger or equal to 101. Then you change to z-score, find your probability. Because they ask proportion, you times 100% and find your answer. What proportion of pistons meets the requirements for reconditioned engines? Recondition is between 99.5 to 101.3. Because this is normal distribution, this is what you put. X more equals to, less or equals to. Find your z-score, find your probability times 100%. Okay, question 9, same thing. But in this case, question 9 is a binomial distribution. Okay, they didn't give you the n in the question here, but they told you the p 0.4. Okay, if the Western Wonders win 8 corner kicks in a game, your n is 8. Exactly 3, find the probability for exactly 3 and that shouldn't be a problem. Won 96 corner kicks, n is 96, p 0.4, at least 40 times. So you pretty much know, and they've also stated in the question that you are going to change it to normal. Okay, so you do it accordingly. Okay, you make sure you put the asterisk. Why? Because this was originally a binomial distribution. Now it is going to be normal. All right, moving forward, question 10. This is a normal distribution. What is the exactly? I already told you, if it's a normal distribution, they ask you exactly 0. No need to do calculation anymore. What is the probability that can contain less than the advertised amount? What is the advertised amount? 375 ml. So less than the advertised, x lesser or equal to 375. So lesser or equals to negative 1.5. That's your probability. Okay, everybody all right there? Okay, if cans are sold in boxes of 24, what does this tell you? It's a binomial distribution, your n is 24. What is the probability of finding at least 2? This is what this part of the question is here. I told you. First part gives you n. Second part gives you the number you are calculating. And the last part gives you the event. Number of cans less than the advertised amount. So n is 24 and your p will be 0.0668. Alright? Alright, so your P will be 0. Where is this coming from? Less than the advertised amount. This is less than the advertised amount. 0.0668. This is where it's coming from. So lesser, more equals to 2, at least 2. More equals to 2, right? So you got to use binomial distribution to solve this. 1 minus 0 and 1 will give you the answer. Alright, so basically that's how you do it. Question 11, this one is quite simple. I'll move on. Okay, find the probability teacher chosen a random owns a Perodua car. We have actually done this before, so it's quite simple. Moving forward, 10% of the cars are 0.1, n is 10. This is just using binomial distribution, so you should be able to answer the question. 12b, a random sample of 100 cars, so your n is 100. Determine the probability that sample not written off. So you must read it carefully, alright? So this event is number of cars not written off. That is why my P is 0.9. Alright, then you will change it to normal because you want to calculate more than 85 cars. More than 85 cars, you cannot be doing it one by one. Alright, so you got to do it using binomial distribution. Approximate to normal, alright? Okay, next question is originally normal. Originally normal, just always remember when you have things like this, the sign should be like that. Always remember, originally normal, make sure it's more equals to, less or equal to, alright? Okay, the number expected to fail in the first 880 in the batch of 200 components is considered. So you find the probability first of the first 88. Okay, that means first 88, so lesser or equals to 880. Find the probability, then you can find the expected number. Understand? Alright, 1,200, same question. Proportion 1,100. Less than 1,100, I want this part. Okay? More than 1,460, I want this part. So I want these two parts, the green parts. Do you see that? There, can you see it here? So do the appropriate calculation. Do it in any way that you think it's easy. So it's 1 minus this inside part. How you want to do it is up to you. I've sent you a video of 3 ways to calculate, whichever you are comfortable using. Alright? Question 14 is just a Poisson distribution. So this one you should be able to do it easily, I would say. Shouldn't be a problem. Okay, time taken for Cindy. This is also quite a repeat here. What's the probability that she's late? How is she late? Okay, she always starts from home at 7:45. She's supposed to get to work at 8:30. So it takes her 45 minutes to travel. How will she be late? If it's more equals to 45. Change it to z-score, so on. I already told you exactly 5 minutes late. Exactly 5 minutes late, a lot of students will tell me, why is it not x equals to 5? 5 minutes late. 5 minutes late means it takes her 45 minutes to travel. That 5 minutes late means it took her 50 minutes to travel. You understand? Okay? So it will be equal to 0 because this is normal distribution. More than 5 minutes late. So it took her more equal to 50 minutes because this is normal distribution. It must be more or equal. Okay, question 16 is just a normal binomial distribution question. So I'm just going to move on. You're going to use binomial to answer it. Shouldn't be a problem. Question 17 is, the first two parts are just a normal Poisson distribution question. Quite easy. I think you've done something similar before as well. This part, yes, it's a little bit, it goes a little different here. You write your original event. It's lambda of 1. Now she will receive no calls. So let's look at this. The first part, during a normal 5-day working week. Alright, so what is this? My N. I always told you, first part of the question, N. There will be exactly 3 days. That's what I'm calculating. Probability of Y equals to 3. You want to use X also, actually, no problem. Don't worry about that. On which she will receive no calls. That will be my event, number of days with no calls between 9:30 and 9:40. Follow this method, you will never go wrong. So my N will be 5. My P must be the probability that there is no call. So you calculate that in advance and then you put it in here. Then you use your binomial distribution and answer the question. Question 18 is just a normal binomial distribution question. So is this. You got to do it one by one. You have no choice because basically you can do it one by one. Okay, 18b, they just asked you to find the mean and standard deviation. This also shouldn't be a problem. Here you have an N of 500. Your P 0.2 given to you in the question. You will have to use normal to answer this question. 84 or more, you do your continuity correction. Why? Because you're changing from initially was binomial. Now you're going to use normal approximation to answer the question. Last question. 5,000 corn cobs from a local wholesalers are measured, all right, and recorded. The lands are found to be normally distributed with a mean of 9 and a variance of 0.25. Determine the random variable X and define the probability. Random variable X is your event and your probability, this is it, okay? Find the probability as between this and this. This is normal distribution, therefore is X more equals to 8.5, less or equals to 9.25. Because it's normal distribution, that's why the sign is like that. If it's binomial or Poisson, if I'm saying between, then the sign is not like that, understand? How many corn cobs could be expected to be over 10 cm in length? Over 10 cm, probability of X more equals to 10. Change to Z-score, that's the probability. Expected, 5,000. Why? Because here go 5,000 corn cobs times the probability. You'll get 114. Alright, so pause the video as you're going along. Okay, if there's anything that you don't know, please reach out to me, alright?